S1, Chapter 1, Lesson 5, so Part 2, Combinations. All right, so now we're going to focus on the at least, at most, kind of using our inequality knowledge in terms of what those mean to make sure we get the appropriate amount of combinations. So the student, this is kind of more just example-based here. A student council decided to form a subcommittee of 5 council members to look at how funds are raised should be spent on students at the school. There are a total of 11 student council members, 5 males, 6 females. How many different ways can a subcommittee consist of? The exactly 3, at least 3, and at least 1 females. So kind of give us 3 little combinations there. So the exactly is kind of easy because we know how many females, right? So exactly 3 means we're going 6C3 for sure on the females. And what's my males? So 5 council members, 5C2. So that one's pretty easy. Okay, it's compared to yesterday, or not yesterday, last lesson. Okay, so then this would be 200. Now what changes when I say at least 3? Could be more. So that means you have more options. So you have this, or that, or potentially that. When I'm saying the word or, that's because or means adding. Okay, so addition. So when you see the at least stuff, you want to come up with all the options. So we know at least 3. 6C3 counts, 6C4 counts, and 6C5 counts. 3 females, 4 females, and 5 females. So we already know what 6C3 would be, that 5C2. You times it, that's your 200. And then it's going to be 5C1. And then you don't have to do 5C0. You can if you want. 5C0 is just 1, so it won't get you anything. Okay, these are C's here. Kind of bad, the subscript with combinations, sorry. Okay, and so if you do that, you're going to get 275 and 6. So 75, 6, and you add all that, you get, there's 281 ways to have at least 3 females. Okay. Now, I did at least 3. So we could do 2 and 1 and then add it to 281, but what's a faster way for at least 1 female? Tricky. Yeah, you can do subtraction. So you can go ahead and say, I can find all the ways to pick people for the council, and then subtract having no females, because no females is the only problem. Okay, so you could do that if you'd like. All right, what's that going to look like here? Oh, they did add them all. Well, they did it both. So you can take this right here, the 281 we just did, and you can go plus 281. 281 plus, so that's the 3, 4, 5. So it would be 6C2, 5C3, plus 6C1, 5C4. So that you can continue the addition way. Okay, if you do that, you're going to get 461. And then over here, I'm going to show you the subtraction way. So what's the thing we don't want to happen? Let's just, that's what we're going to subtract. How would I demonstrate that as a combination? And so what is that? 5C5, good. Now, how do I write all possible ways of selecting 5? 11C5. So when you're talking about all possible ways, you combine the genders because you're finding out all ways to select 5 from the 11. Okay, the 11 is the guys and girls together. So 11C5 demonstrates every way that you come up with a committee with no restrictions from that 11 groups they give, or 11 people they give you. And so what we do is we subtract the ways that you choose all guys. Okay, and then you get 461 again. Okay. All right, and so we're going to use that a little bit here as we get closer. So when you have like at least 1, it's better to do the negative, like take out the negative so you don't have to add so much. Okay, so another card problem here. Consider a standard deck of 52 cards. How many different 5-card hands can be formed containing at least 1 red card? So then we want to go ahead and then do all combinations, subtract. Right, so every way to get a card is 52C5, right? And so what don't we want? Five black cards, which would be 26C5. Jeez. For this part? Yeah, so this stands for all combos. This stands for all black. So if I do all 5 card combinations in red and black, it doesn't matter, and I subtract when I get all black, I'm going to have at least 1 red left. Does that make sense? Yeah. Okay, so if you do that, it's going to be the big 259 number minus 65,000. So it's going to be 2,533,180. So 2.5 million still. There's still quite a bit of ways you can have at least 1 red card, which we kind of knew because all black would be a flush, or not all black, but there's a lot of ways. At most, 2 kings. So at most means we want 2 kings, 1 kings, or no kings. Okay, so 2 kings, 1 kings, or no kings. So we want 4C2, 4C1, and 4C0. Best way of this one is to add them. Okay. You could subtract if you wanted to take a little bit. It'd probably be about the same, actually. So 4C2, if I have selected 2 kings, I need to get 3 non-kings. Okay. If I selected 1 king, I need to get 4 non-kings. And then here, I need to get 5 cards that aren't kings. And so then we're going to add those. And so there's going to be quite a bit here because you should expect this number to be big because getting no kings is pretty common, right? Getting 1 king isn't super rare. That's why it's not even a hand. And getting a pair of kings is kind of good, but not great. So like you're kind of asking like very common combinations here. So that's why the number when you do this is quite high. It's 2594 and 400. So just for fun, let's just do this just so I can show you the total here. Okay, can somebody divide that for me? What is that divided? As like a decimal. Just I want to show you something. It's not part of the problem at all. What is it? Oh, should just somebody do it? Okay. This is the total. Okay? Correct. So what I'm trying to show you was, so Janet, you asked a question. This is the total number of combinations of 5 card hands. That's that big number we had at the beginning. So this is how many ways you can have at most 2 kings. Okay? So that, I'm showing you there's a lot of ways. You have a 99.8% chance of getting at most 2 kings. So what's rare? Getting 3 kings. That's really rare. That's what I'm showing you. Okay? So to what Owen said, 99.8% chance you would get 2 kings or less. Okay? So that's just food for thought. Nothing, you don't need, we're not doing probability in here, but just food for thought. Okay? Exactly 2 pairs. So this is a little bit tricky. Exactly 2 pairs. I'm actually going to pause the video. I want you to just talk to the person next to you and just think if you can come up with a setup for this. All right, so yeah, good practice there. We did get it. So let's talk about exactly to Leah's point, how do you look at that and say that's correct? So this is how. So we want 2 pairs. And so we know that all cards, to have pairs, there's 4 cards of the same kind. So 6, 6, 6, 6, whatever. There's 4 of them. Well, we need 2 pairs of these. Okay, so there's your 4 C2s. So this is 4 same card, pick 2 of them, 4 same card, pick 2 of them. There's your 2 pairs. Well, we want a pair. So 2 pair means like having 2 kings and 2 queens. Exactly. There's my first pair, there's my second pair. Okay, and then our 5th card, we don't care what it is. Not 44, or not 48, I mean. There's 44 cards we can choose from to get a 5th card that won't match a pair of these. So this is your 5 cards, and I thought a lot of you guys could get that part. Okay, but it's okay if you can't. No, I know, I apologize, I shouldn't have said that. But the Point is that there's your 5 cards. The tricky part is the 13. Besides Jaden, does anybody want to explain what the 13 means? Besides John. Even though you guys kind of together. Okay, so this is the answer. What does a 13 represent? This 13C2. Jake? No? Not, yeah, that is, but what does a 13C2 mean? So he said the 13 is the 13 cards in a suit. He's correct. Okay. Close. You're essentially right, but just one little word there, Langley. This is how you pick what pairs you have. There's 13 types of cards you can pair. You need how many pairs? 2 pairs. 13C2 accounts for that. So this is selecting what cards these are. Because this right here by itself is just simply how many ways to get it. Like if it was just 6, 6, 8, 8, and then a king. But then we got to figure out how do you pick 6, 6, and 8, 8. How many combinations that are possible. That's what this takes care of. Okay, so this part is selecting the pairs.
Like the number.
Exactly. That's how many ways to select the pairs. Okay, definitely a challenging question there. The 4, so the 4 is every card has 4 of them. 4 6s, 4 8s. Yeah. Okay, any other questions to that, clarifying that? Good job, that was good. Good, even though you got stuck, that's the challenge, it's good. Okay, so we're going to talk about now just kind of the symmetry of combinations. So we're going to talk about a little point here. Okay, so Fran and Bernie have identical collections of vintage toy vehicles. Fran collects 2 toys from the 10 shown in his display cabinet. Since the order of display does not matter to her, she calculates that this can be done by 10C2. So that means she's just taking groups of 2 and putting them in the display cabinet. So how many ways can she pick 2 of her vintage toys? Is 10C2, that's 45. Bernie selects 8 toys from the shown to his display cabinet, and he gets 10C8, which is also 45. Why does that make sense? Why? Right. So yeah, in a sense, but also just look at this. If I select just 2, what's left out? If I select 8, what's left out? That's the same answer. How many ways I can leave 8 out is the same way as how many I can leave 8 in. So the symmetry of 2 and 8 is because the left out and left in is essentially symmetric. Okay? So 10C2, if I take 2s, there's 8 left over. Is the same if I picked 8 and 2 are left over. There's going to be the same amount of combinations of that. So if I did 10C7, what's the symmetry one with that? 10C3. Yeah, it's that one that completes the combination number. Okay, 8 plus 2 is 10. That's not a coincidence. So 10C6 and 10C4 are going to be identical as well. Yes? Right. Yeah. In this case, because of symmetry, yeah. Okay, so then, anyways, it's because if you choose to, eight are left out, which can be viewed as selecting 8. And leaving 2 out. Okay, and then we'll use the factorial notation to show why here in terms of the algebra part. So I said if you choose 2, 8 are left out, which can be viewed, as selecting 8 and leaving 2 out. It's a very similar setup. Okay, so then for B, let's just do the factorial part here, show what it looks like. So for B, we have 10C2 and factorial notation is 10 factorial over 8 factorial 2 factorial. And then you'll see that 10C8 is 10 factorial over 2 factorial 8 factorial. See, it's the same thing. The bottom just got switched order. 2 factorial times 8 factorial is the same. Okay, and they both get you 45. So go ahead and just give another 2 examples of equivalent combinations. So I'll do 14C4, 14C what? 10. Good. Okay, you can write your own if you like. And so they just kind of give you this little formula, general rule for it. NCR is equal to NCN minus R. So what they're saying is, see, 14C4 is the same thing as 14 minus 10. 14 minus 10 is the 4 again. So it's just kind of a form for it. And they want me to algebraically show this. They want me to do the factorials. Yeah, okay, it's just a little bit messy, but we're just proving it. All right, so if I just use my factorial formula, just the previous pages that we went through, n factorial over n minus r factorial times r factorial equivalent to n factorial over n minus r factorial n minus r factorial. I'm just plugging the formula with the letters they gave me. I know it looks ugly for the second one. So I'm going to go ahead and just simplify the first one, or sorry, the second piece, this piece, and just see what I get. Okay, so this piece simplified, n minus n cancels, okay, and the negative r makes it an r factorial. So this essentially is, which is the same thing. Just that one little quick step. The n's cancel, negative r makes an r factorial, and I have the n minus r, it's already matched. Just showing you it's the same thing. Okay, they like handshakes problems on your assessments and diploma. Handshake is definitely a combination, because if I shake John's hand, he shakes my hand, we don't count that twice. We don't care the order in which we shake hands. Our shook of a hand is one thing. Okay? All right, so during Pee Wee hockey tryout, all the players met on the ice after the last practice, shook hands with each other. Algebraically determined the number of players who attended the tryouts. There were 300 handshakes in all. Okay, so what do we know and what don't we know? Okay, good. So we know that NCR equals 300. Do we understand that? The output of handshakes is 300. Do we know anything else? We need to know one more thing. We can't have 2 variables. We do know one more thing. Do you know what it is? I should say. There is 2 teams, but that's not really going to help us in the context of this. But 2 is a number I want you to tell me about, though. No. Right. So you say what? Sure. Correct. So that n or is that r? What's r? R is 2. It takes 2 to shake a handshake. Now, Janet, you said 150. That's a very common misperception because that's if everybody shook hands once. No, I'm just saying if we all just stood in a line, there's 150 of us, and we shook a hand, right? That's what she's thinking. But that's not what we're talking about. We're talking about if in this classroom right now we have, let's see, 2, 4, 6, 7, 8, 10. We have 12. Doesn't mean we'd have 24 handshakes, right? It'd be 12 C2. Because 12 of us, how many ways can we shake hands as C2? Because it doesn't matter the order. So this case, what we're doing is we're trying to figure out this. And this is what you need to be good with your algebra. Now we need the formula. Okay, NC2 is what we're solving. We're solving for the number of people at the practice. So there's your setup. See how we only have an n now? So let's talk to me here. What do we want to do algebraically here first? 2. This is a 2. Yeah. What would you do first algebraically here? You want to walk down first? You can. Sure. What's bigger, the top or the bottom? This is, right? So we walked it down to n minus 2. And you canceled the n minus 2. Okay, so we're left with this now, and then I'll see if you guys are with me still. This is where we're at now. Everybody okay with that? Now what do we want to do algebraically? Okay, don't be psyched out by the factorial, because walking down the 2 won't really do anything. It'll just be 2 times 1, right? Right, the 2 factorial is just 2. Or just, remember, this is a number. Don't be confused, like don't view variable here. Okay, but yeah, we just times this to both sides. 2 factorial is 2 though, guys. You can call it 2. You don't have to make it a 2 factorial anymore either. So now you're here. I'm going to go and distribute the n squared minus n equals 600. 300 times 2. Now you can see it's starting to shape up. We're solving a quadratic now. We minus 600 over. Can we factor? So factor the 600 that are 1 apart. I believe, what was that? 25 and 24. What is it? Yeah, it's 25. N minus 25, n plus 24 was its factors too. Remember, we're going for people, so we'd reject the negative 24. So the answer is there's 25 guys at the practice. So there's 25 people at the practice. That's why you need to know how to use the formula, okay? Because they can do stuff like that too. You don't know n or you don't know r, okay? 2, because it takes 2 people to shake a hand. So it's like when I'm asking how many handshakes are possible, the people in the room is going to be chosen in 2s, because handshakes don't happen in groups of 3, right? And so that's kind of why. Yeah. No, that's a common question people forget. Handshakes happen in pairs. Okay? All right, let's finish this up here. All right, polygons and diagonals. So a little bit of geometry with combinations. Consider circles with 5 points marked on the circumference. Circumference, remember, is distance around a circle, if you forgot. How many triangles can be formed using 5 points? Write the answer in combination notation. So your question is, how many points are there? How many points do you need for a triangle? 5C3. Okay, so there's 10. There's 10 possible triangles. Okay? Okay, then how many lines can be drawn on the circle? Write the answer in combination notation. Oh, we should know that answer, shouldn't we? Also 10. Right? Because 2 and 3 is the flip of each other. The symmetry. It says sketch a regular pentagon. Whenever you're sketching a regular pentagon, regular just means they're all equal sides. Pentagon is 5. So just do the best you can. Okay. It says how many lines can be drawn connecting 2 points on the pentagon, including sides of the pentagon? So what that means, how many lines can be drawn connecting points? So if I just do these as points, it says how many lines can be drawn connecting 2 points in the pentagon. So there's how many points? There's 5, and they're saying that we can connect the sides. So that does count. Okay, so then what would you do? It's still 5C2, yeah. You have 5 points to choose 2 spots. So if you did that, there'd be 10 lines you could draw. Okay? So 5C2, how many lines? So we just did that, sorry. That's right there. How many of these lines are diagonals of the pentagon? So diagonals, we would not count the what? The sides. And so how can we account for that? So one thing that you can kind of look at, if I do this here, right? Every spot I'm at, I have how many? I have 4 lines to draw, right? So of those lines I draw, how many of them are sides of the pentagon? And how many are diagonals? So you just divide this by 2. There's 5 diagonals that you could draw. You could also just play with that one too if you wanted. You can say it was 1, 2, 3, 4. There's one more I got here. Where's it at? 5. Get that kind of star there. Yep. Now Lizzie's in. Stars, smiley faces, happiness. Okay, no, it's good. Express the answers to I in terms of combinations, and so the combination of the one we just did would be number of lines minus number of sides. So it would just be what we just did, 5c2 minus 5. There's actually a formula. We divided by 2, but it's really just subtracting the sides, because the sides we don't want to double count. So there's 5 sides, and so it's a formula you have here they have for this. So how many diagonals in a regular octagon? It'd be 8c2 what? Minus 8. Okay. And then just the formula which we're coming up with, it'd be nc2 minus n, which they have right below there. Okay, and we'll just finish this last one here. All right, so of course, you see the word algebraically, so we're going to have to work backwards using this formula. So it says a polygon has 65 diagonals. Algebraically determine how many sides it has. So that means is, within this context, we know the answer is 65. But what do we do now? Well, first thing is, let's get rid of this subscript. We want to write that as it's supposed to be. So write n factorial over your n minus 2 factorial, 2 factorial. We can move the n over, you can leave it, it doesn't matter right now. I think I move it over just to make things a little bit cleaner for a second, just so that I'm just focused on this. So again, looks like we want to do what next? Walk down the n, yep. So we walk down the n, so I'm going to come up here. It's going to be n minus 1, n minus 2, n minus 2, and then the 2 factorial, cancel. I'm just going to call 2 factorial 2 if that's okay with you. And I'm here. What do I do next, Lizzie? Yep. Multiply the 2 on both sides. And remember, to everything, because I have 2 things over there. So now we're at cancel n squared minus n equals, that's 130 plus 2n. Move that stuff to the left and solve that quadratic. N squared minus 3n minus 130 is 0. Not too bad of a one, because 13 times 10 is 130, and 13 times 10 is 3 apart. So we're here. We reject the negative 10, because you can't have negative 10 sides, so it would be a 13-sided figure, would have 65 diagonals. Okay. All right, stopped.